Hey everyone, today we're finishing up Notes 1-2 Attributes of Functions. So I want to remind you what we discussed last time, and that was we found X and Y intercepts graphically, and we also found min and maxes graphically. So we found all those attributes graphically. Today we're going to want to find those same attributes, but algebraically. So let's first start with X and Y intercepts. So remember, the X-intercept is the point at which the graph crosses through the x-axis. So in this case, the X-intercept was 2, 0. But what if I had a different graph? What if the graph looks something like this and it crossed through, say, right here? So that X-intercept would be -3, 0. What if it crossed through right here? That X-intercept would be -1, 0. I hope you're kind of seeing a pattern. Okay, what is that pattern that you're seeing? Every X-intercept will always have what? Well, it will always have a y value of 0. No matter where I land on the x-axis, every single one of those ordered pairs has a y value of 0. So that's exactly how we're going to algebraically find an x-intercept. So to find the x-intercept algebraically, you will plug in 0 where you see y. Okay? And similarly with a y-intercept, so I know this y-intercept was 0, -1, but say I had a different graph that crossed through maybe here. Okay, that y-intercept would be 0, 3. Or maybe I have a graph that crosses through here at 0, 4. Are you also seeing a pattern? Okay, so every single y-intercept will always have an x value of 0, right? So similarly, that is how we're going to find y-intercepts algebraically. We will plug in 0 where we see x. So we'll talk about why this makes more sense here as we get going. So I know we've already graphed this and found the x and y-intercept, but let's go ahead and use algebra to check our graph and make sure those things coincide. So first we'll find the x-intercept. And remember, to find the x-intercept, you will plug in 0 where you see y. So I'm going to take this equation here, I'm going to plug in 0 where I see y, so 0 equals 1/2 x minus 1. Remember, make sure that x is in the numerator. Okay, and then of course I'm going to isolate x. So again, it makes sense that I plugged in 0 for y, because when I'm finding the x-intercept, the only variable I see is x. So I want to isolate that x, which means I'm going to move this -1 across the equal sign. So this will become +1 equals 1/2 x. And of course, I still want to isolate the x, so I'm going to multiply both sides of my equation by the reciprocal of 1/2, so 2 over 1. Okay, 2 over 1 times 1, of course, is just going to give me 2. And then here, the 1/2 and the 2 over 1, the 2's are going to simplify out to 1 and 1. And of course, numerator times numerator, denominator times denominator. So 1 times 1 is 1, and 1 times 1 is 1. So that's just going to give me 1x, or x. Okay, that's perfect. That matches our x-intercept here. Now, of course, for your final answer, still, even though we're doing the algebra, you'll still want to write your final answer just like this as an ordered pair. So that's good news that it matched. Let's try the y-intercept. So recall that the y-intercept, you will plug in 0 where you see x. So let's go ahead with that. So we've got y equals 1/2. Where I see x, I plug in 0 minus 1. So the good news about finding this y-intercept is I don't need to move anything. Y is already isolated. Okay, I just need to figure out what this is. So 1/2 times 0, of course, is 0. And 0 minus 1 is -1, which is also really great news that that matches what we found graphically. So again, you wouldn't want to leave your final answer like this. You would have to write your final answer as an ordered pair. Okay, let's look at number 2, and let's thank our lucky stars that we're not graphing, because imagine graphing that y-intercept. That would be awful. Okay, that's too high. So let's find the x-intercept algebraically. So to find the x-intercept algebraically, I'll plug in 0 where I see y, and I will isolate this x. So in this case, me personally, I'm not going to move over the 17 because that leaves me with more work. I already see this as a -x, and if I jump it over the equal sign, that's going to make it a +x, and therefore I'm going to have +x equals 17. Now, of course, you can't leave your final answer like that. We're going to come up here and write 17, the ordered pair 17, 0 is our answer. Okay? And then here for the y-intercept, I know you already know this is in slope-intercept form and the y-intercept is 17, but let's prove it algebraically. So algebraically, I'm going to plug in 0 where I see x, and then I'm going to just, since the y is already isolated, I'm just going to figure out what this is. So negative 0 is just 0, and 0 plus 17 is 17, so my y-intercept is 0, 17, as we anticipated. Okay, so moving right along. Number 3, x-intercept. So again, I will plug in 0 where I see y. Okay, 2/3 x in the numerator plus 6. So again, x is the only variable I should see since I'm finding the x-intercept. I'm going to jump across the equal sign here with that 6. So that's going to be negative 6 equals 2/3 x. And then I'm going to multiply by the reciprocal of 2/3, which is 3/2 on both sides. And of course, since this negative 6 is over 1, let's see if I can simplify. So obviously, I can't simplify this here, but I can simplify this. Both of those numbers are divisible by 2, so this would be turned to a 3, and that would turn to a 1. So 3 times negative 3 is negative 9, and it's over 1, so I don't need to write it. And then, of course, here, these all simplify, so I just am left with x. And I can't leave my final answer like that. I write negative 9, 0 as an ordered pair, and then I box it up. Okay, y-intercept. So y-intercept, I'm going to plug in 0 where I see x, and that makes sense because the only variable I see now is y. So here my variable's already isolated, so I just leave it where it is, and I just figure out what this is. So 2/3 times 0 is 0, and then 0 plus 6, of course, is just 6. So 0, 6, and I'm done there. We're almost done with this. Okay, next. So y-intercept here. Or excuse me, x-intercept here. So plug in 0 where I see y, negative 2, what am I doing? Negative 2x plus 1/4. Okay, and you kind of have choices here. Again, kind of similar to the problem above. I see that that x is negative and I don't want to deal with the negative x, so I'm going to move him over the equal sign. And I'm going to say this is 2x equals 1/4. Let's talk about this for a second. You're probably yelling at home, oh, divide by 2, right? But ooh, who wants to deal with a fraction over an integer? You're going to have to worry about keep it, change it, flip it, etc. So instead, to get rid of this 2 or 2 over 1, let's multiply by the reciprocal being 1/2. So multiply by 1/2 on the left, multiply by 1/2 on the right. So then, of course, this 2 over 1 simplifies through, and this just becomes x. And then this is 1/8. So my x-intercept here would be 1/8, 0. All right, last piece here until we get to the back. So now, y-intercept. So y equals negative 2, where I see x 0 plus 1/4. So y equals 0 plus 1/4. So as you already knew, y equals 1/4. So 0, 1/4. Well, look at that. Just as we anticipated. All right, so of course, if it's not in slope-intercept form, then, you know, it's not quite as easy maybe. All right, so min and max, let's remind ourselves. So for min and max, remember we found the lowest and the highest y value within the bounded region or even including the border, okay? So we did that graphically. Now, I hope you noticed that if you have a line, something that I'm kind of going to point out, and hopefully you already kind of noticed, if you have a line, whether it be an increasing or a decreasing line. Now, I'm not talking about your horizontal and your vertical special cases. I'm talking about a line with either a positive slope or a negative slope, not a slope of 0 or undefined. Then, of course, your highest and lowest point are always going to be on the borders, right? It's always going to be your lowest and your highest, or if it's a negative slope, your highest and then your lowest. So how do you algebraically find those values when you're dealing with a linear equation? So that's not bad at all. You simply compute f of -1 and f of 3. Didn't you notice that that's here what we had for our answers, f of negative 1 equals and f of 3 equals. For a linear graph, it will always be the boundary. So that's the value we'll compute. So let's go ahead and algebraically compute f of negative 1. So remember, we can really rewrite this as f of x equals. So f of negative 1 equals 2, where I see x, plug in negative 1 minus 2. And here for f of 3, I would have 2 times 3 minus 2 when I plug in 3 for x. So here when I do this math, f of negative 1 equals negative 2 minus 2. So f of negative 1 equals negative 4. Does that match? It sure does. Okay, so we're going to box that up here in a minute. And then f of 3, this would be f of 3 equals 6 minus 2. So therefore f of 3 equals 4. Does that match? It sure does. So your final answer should look something like this. Okay, so now let's go on to the next problem here. In fact, we're going to skip that one just for sake of time. So let's move on to this problem here. So what we're going to do is we are going to compute f of negative 9. That's our leftmost boundary. Okay, and that's going to be 2/3. Where I see x, I plug in negative 9 plus 6, and I'm going to compute f of 3. Remember, that's my leftmost boundary, that's my rightmost boundary. I'm going to compute both. So f of 3 is going to look like 2/3. Where I see x, I plug in 3, and then plus 6. Yes? Okay, so now f of negative 9 is going to equal, put this over 1, and then this will turn to 1, this will turn to 3. So 2 times negative 3 is negative 6, and then it's over 1, plus 6. So f of negative 9 equals 0, okay? And then here, f of 3 equals, this is over 1, and those actually just simplify to 1, so this just becomes 2 plus 6, which is 8. So f of 3 equals 8. Well, I wonder which one's your min and which one's your max. You guessed it. 0 is definitely lower than 8, so that's my min, and this is my max. Not terrible, right? Okay, and let's talk real quick about why this made sense. So my left boundary was my min, and my right boundary was my max. And that makes sense for this positive slope, right? So again, when you have that positive slope, your left boundary will be your min and your right boundary will be our max. So let's see if that's true in number 4. So on number 4, my boundary is negative 1 to 2. So I'm going to compute f of negative 1, which is going to look like negative 2, where I see x, negative 1 minus 1/4. Okay, and then I'm also going to compute f of 2. So remember, these numbers came from, that kind of made it fuzzy. These numbers come from the boundary. F of 2 would look like negative 2, where I see x, plug in 2, minus 1/4. Okay, so f of negative 1 equals negative 2 times negative 1 is positive 2 minus 1/4. And then to get that common denominator, this would look like 8/4 minus 1/4, right? 8 over 4 is 2? Yeah, it is. Okay. So this would be f of negative 1. Oh, why am I doing a fraction there? I'm losing my mind today, people. Okay, f of negative 1 equals positive 7/4. Okay. And then here, f of 2 equals, this is negative 4 minus 1/4. And then I'll have f of 2 equals, this will be, multiply this 4 over 1 by 4 over 4, so that'd be negative 16 over 4 minus 1/4. So this would be f of 2 equals negative 17 over 4. So obviously this one's lower, it's a negative output. So that's going to be my min, and this is going to be my max. So does that make sense this time, that my left boundary is my max while my right boundary is my min? I hope you're saying yes, because we had a negative slope, and remember, a negative slope looks something like this. So on the left side I have my max, and on the right side I would have my min. So that makes sense based on the fact that this is a negative slope. Yay, we're done for today.